Now, you all can listen about the concept of your DC generator and write the content later on, everything, okay? So, you know very well what is a DC generator. You would like to generate a voltage of DC, direct current, with the help of a setup. The setup consists of a magnetic poles. You know that very well. We make use of a north and the south poles. Definitely, obviously. What happens? I told you always the direction of the magnetic field takes up only from the north to the south and not from south to the north. Okay, that is one aspect. And in the previous class, what we observed is that in a DC motor, you will be fixing the same poles of unlike. Okay, and there will be a magnetic field. So what you place in between that is that, so you have the magnets and there will be a magnetic field will be there. You try to insert or place in the middle of the magnetic field where you identify a copper wire having a current. That is what a current carrying conductor. So how you identify it as a current carrying conductor is that you will be fixing a battery. So that we discussed thoroughly. So what happens? You will be connecting a commutator over there, right? So what is the statement I have given is that the commutator is the one that could able to, what is commutator? Commutator. In DC motor I am asking. So what is the point given to you?
Providing the current.
Providing the current to the armature winding and then in a DC motor, correct? So you have the armature windings will be there, which is the coil, okay? So you say again, it's a recall, you have the two poles, you have the magnetic fields and you try to connect the current carrying conductor. So what happens is that, so by means of a commutator. So the commutator is the one which could able to hold your armature windings, right? So the armature winding could able to pass the current to the armature, okay? The commutator is the one, I repeat, commutator is the one that could able to provide the current to the armature. Current to that is the motoring action. Motoring action is the one you pass the current, then only the motor rotates. Whereas now we are coming to the DC generator and alternating action. We are not passing the current. We are providing a mechanical energy and then we try to get the current from that mechanical energy what we have given. Input is mechanical, rotating, and you retrieve the electrical, DC power. So now what happens is that again the same setup being used, two poles of unlike. So obviously there will be a magnetic field from north to the south. You know that very well. You will be keeping a coil over there, what is called as a armature coil. That is holding a what? A current carrying conductor. Current carrying conductor. Okay, so anyway, so now you see, you keep this. You identify the lines are parallel. So what happens if you keep the magnet, it automatically gets attracted like this. Yes, not from this, only in one direction, all the time north to south. So you keep a armature coil. What happens is that, so it's what your armature coil is identified like first you need to analyze or identify the position of the the fields you see. First 1, 2, 3, 4, 5, 6, 7 is there. So you identify the position first of all. First you have to have the imagination like this. Okay. So you see here armature coil is there. So already the field is like this. It's going okay. You imagine again. So north to south. Field is there. You keep this. And what happens is that when it is parallel, it could not able to cut your magnetic lines. Unless or until your copper wire cuts the magnetic line, the EMF will not be generated. You imagine what happens. So here I could not able to predict your dimensional view. It's your imagination, very important. Okay. So what happens is that first it will be parallel. And then what happens slightly. So if I keep on rotating like this, what happens? Initial position is a parallel. You could not able to identify or notice that the conductor is cutting your magnetic line. Next what happens? Further it gets rotating. So what happens? It comes to the position 2. Slightly it cuts. And you will see, and then still it is rotating. So what happens? It takes up the maximum thing where it cuts the your copper conductor tries to cut the magnetic field to a maximum. Okay, so what happens? It is maximum. And then again it it is rotating. So your thing is A, B and C, D position is there of your armature slot or armature coil. So what happens? It tries to rotate. Here it becomes parallel to the magnetic field, and then it's quite parallel and it is also quite perpendicular. So it comes to the position 2. So when it comes to the position 3, so what happens? Thoroughly it is, the lines are, so the two poles are there, the lines are coming like this. So what happens? When it comes to this position, exactly it is cutting thoroughly. All the copper conductor is connecting. So what happens? It is crossing over the magnetic field. So obviously a copper carrying conductor is placed in the magnetic field, it generates an EMF. So the EMF will be maximum at the position 3. Again it is going to like this. So quite somewhat parallel and quite somewhat perpendicular. Again what? It starts reducing. What starts reducing? The EMF is reduced. Again it coming to this position. Again it's towards 0. Again it coming to this position. Quite somewhat less EMF. Again it comes to this position. Now you see it is maximum. That is what the case we always predict a waveform to be. The AC signal, what you call it as a sinusoidal signal, we represent it in this form. Initially it is a 0, okay, in one position. Why? Because the lines are here, you see, it is not at all cutting your copper conductor. So when you keep on rotating, it starts somewhat. Yes, you get, this is what called as the measurement of the voltage. So 5 volt, 10 volt, 15 volt. What is the maximum voltage that you obtain for this setup is 15 volt. That's it. So when it is maximum, it is more perpendicular to your magnetic field, you will get more maximum voltage. This is what the concept or the base. Okay, and that is the concept. And when it gets keep on rotating, it comes to the position 4, it is reduced. And you see position 3, position 4 it is reduced, position 5 is maximum, and again you see 5 is reduced, and again you go for a 6, it is maximum, and 7, 6 quite maximum, 7 more maximum, 8 somewhat reduced, and then again comes to the position 1. So it keeps on rotating like takes up a clockwise rotation. This is what the concept why we always represent the 230 volts 50 hertz frequency. How you denote the 50 hertz frequency? Yes, of course based on the time period. So one complete cycle it is called as a T. T is equal to 1 divided by F. We know the formula. So what is time period? You see, if it is of a 1 millisecond, it is equal to 1 millisecond. That is T is equal to 1 into 10 power 3. So what is the frequency then? F is equal to 1 divided by T. So you will be getting the hertz or as after you estimating. So this is the concept how we will be getting or we will be representing always a sinusoidal signal for an AC waveform or AC signal representation. So we are not simply, we can also make use of representing sinusoidal signal like this. Why we not? Because having this concept, that is the place. Okay, and also yes, that is what written over here. That's it.